Hey everyone, this is Steve from GamersNexus.net, and I am joined by hardware editor Patrick Stone.
Hello, GN.
And today we're doing a video on how to build a computer. We have all the guides of the parts to use, but haven't actually talked about how to properly assemble it, so that's what this video is for. And first off, there are three main requirements for building a system. So you need a screwdriver. That's number one. This is a screwdriver. And then two, you need the parts. So we have all the parts here, and we actually have full build listings in the description below if you need help finding compatible parts, if you're uncomfortable picking them yourself. And then three, ideally not required but seriously recommended, is an ESD wrist strap. And what can you tell us about electrostatic discharge?
Well, so the ESD is basically bad news for your expensive components. If you don't want to trash the stuff that you just spent a bunch of time choosing and paying for, then this is what you need. And really, these guys are super cheap. $5 or $6, so I guess super low in price, not actually cheap. And what it does is it takes the static electricity off of you, sends it to a ground, and what that does is it prevents it from going from you to the board or from you to the CPU, sends it from you to the ground. And here's the idea behind that. These components on here are working at 3.3 volts, 5 volts, 12 volts. The CPU down at like 1 volt, you know, plus or minus a quarter or whatever, right? And if you can actually touch the component or whatever it is up here and feel a static shock, the same as if it was like a cold winter day and you touched the door handle, then you've released somewhere around 2,500 volts. You do the math, 12 versus 2,500, dead board, okay?
DED, dead.
Yeah, there you go. Steve, finish it off for us.
So we're just going to get started building this, not waste any time. For our parts, and I have a list of this below, if you need some help choosing a high-end system, we're going to start with the NZXT Phantom 530 provided by NZXT. It is a mid-tower case and will fit everything we have here. ATX form factor is important to know. The CPU is an i7 4770K, which we can easily overclock. We're using the stock cooler for this for tutorial purposes. I would strongly recommend an aftermarket cooler. We have several guides on that below. Motherboard that the CPU goes into is an MSI Z87 G45 gaming board, the red and black board with a Z87 chipset for overclocking and other features. Provided by Antec, we have a high current pro power supply, 1300 watts with an 80 plus platinum ranking, so it is a seriously efficient power supply. Provided by Kingston, we have HyperX Predator memory, which is stock clocked at 2133 megahertz, easily overclocked. The SSD is a Samsung 840 SSD, and this one is 250 gigabytes, so we're going to use that. We have a generic hard drive, and then for the video card, we have an EVGA GTX 760, of course, by NVIDIA. So throughout the build process, be sure to reference all the links in the description below. I have a ton of resources for you, including a full article guide on this process with a ton of smaller tips and cable management tips, component selection tips, PC builds, and our support forums, which are always free to ask a question. So we're just going to get started. I would generally suggest building your system outside of the case first, because if you get a dead on arrival component, a DOA component, your board doesn't work, your power supply is dead, you don't want to go through all the time of putting it in there and finding out. So we're just going to start with building, basically mount the CPU, the cooler, the RAM, and basic connections. And once we know it works, we'll put it in the case. Okay, so now we are going to move to building the system outside of the case.
And one of the things you guys want to be aware of is ESD, or electrostatic discharge. We rigged up something here. If you're not sure about what we're doing here, then don't do this. Safety first, right? But once we've made sure we're ESD safe, we're going to move into installing the CPU. We're going to remove this lever and pull the gate up, and that's going to give us access to the CPU socket. Once we've done that, we're going to take a look at the CPU, find this little golden arrow head corner, and then we're also going to look at the notches, which are toward the back side of the CPU. We're going to use those to help us orient the CPU as we lay it into the socket. And I do mean lay it in there. It shouldn't take any force at all. You should just be able to turn it over, drop it in there, and then begin closing the gate. The gate really should go down very easily. Just make sure you get it underneath that little screw that is on the motherboard. And then once the gate's down, it will take a good bit of force to push the lever back into place.
Yep, so just push it back down and don't panic if it takes a little bit of force. as long as you install the CPU without any extra force than necessary, then you're good to go. And at this point, we are ready to install the CPU cooler. So we're using the crappy Intel stock cooler.
Indeed.
And an aftermarket option's good. Check our links in the description below for those. For the stock cooler, you just line up the cold plate directly over the CPU, and then we've got the 4 screws that line up with the holes in the board.
We're going to just go ahead and snap these guys in. Just make sure that the arrows aren't pointing directly at the CPU cooler if you're using this Intel stock one. And you'll feel a really, really good snap as they click in. And that's going to let you know that it is on there and it's definitely making great contact with the CPU's integrated heat spreader.
Yeah, and once it's locked in place, we just have to connect the PWM fan pin to the board. So make sure you're using the CPU pin, not a system fan pin out. And that connects up near the heatsink on this board toward the top. And now we're ready to move on to RAM. So with the CPU heatsink fully connected, RAM, you just really drop it in, same idea. We have these latches that we're going to open up and then line up the pins on the bottom of the module with the pins on the receiving side and push it into place. It should snap into place. There shouldn't be any undue force necessary. And once you hear that snap, the latches will close on their own, and that's how you know that it's good to go.
And you might be wondering how we knew which slots to put it in. If you're only going to use 2 modules on a 4-module motherboard like this one, you're going to have to refer to the motherboard manual, and it's going to tell you which module slots if you want to insert it in. So as you're doing that insertion, just make sure that the notch lines up with the slot properly.
And it's important for dual channel functionality and other features to make sure you're using the correct slots.
That's exactly right.
And some boards will show those labeled on the board. So finally, we need a video card. If you don't have onboard video supported by the motherboard, that's pretty easy. Drop it into the PCI Express slot. It will snap into place just like everything else. And then if you have onboard video and your CPU supports it, don't even bother with the video card right now unless you want to test it. So we are going to plug in some power. We just need the CPU power, normally 8-pin up near the CPU. We need 24-pin power near the RAM, and then we need the video card power if necessary. Once all of those are connected, again, pretty easy, we're just going to jump the power switch header on the board where your switch would plug into. Some boards will have an on button built into them. You can just hit that. So to jump it, you just take a screwdriver and check your manual for which one is the power switch. That would normally be PWR_SW. Check for that pinout and then bridge it with the screwdriver and your system will turn on as we see here.
Yeah, and you'll note that I had forgotten to turn the power supply on first. That's certainly a necessary beginning step.
This is true. And plug it in. Don't forget to plug it in. And at this point, it should turn on. So we are ready to move the board into the case. The only thing you have to do is remove the power, remove the video card, and then we will reinstall those items once it's mounted in the case. So for installing your power supply, we're just going to drop it in. Your fan should be facing ideally the bottom of the case if it is a bottom mounted power supply. Drop it into the slot. There's a holder right there. Hit the 4 screws and that's it. Before installing the motherboard, we want to mount the I/O panel shield, which just basically goes in the back to stop stuff from falling in. Do this before the motherboard's installed. Line it up, pop it into the spot in the back of the case, and now we can install the motherboard. Before installing the motherboard though, make sure you have your standoffs installed in the case. You can see they're pre-installed on this Phantom 530. If not, then put them in the appropriate ATX or MATX slots. So here we're dropping it in. The CPU stays toward the top of the case. Line up your I/O with the I/O panel in the back. And that's really it. Make sure your standoffs are lined up with the screw holes. Screw them all in. Don't leave any unscrewed for shorting purposes. And then we can move on to the drives.
Okay, the next thing we're going to do is we're going to go ahead and install the optical drive. The optical drives could take screws at these points right here, but not a big deal. Now all you got to do is reach inside the case, pop out the filler plate. These ones on this NZXT case just kind of have a little spring load. And then it's all toolless now. There's no screws anymore. So you just kind of lift up the release lever like that, slide your drive in, and you're done.
Yep, and then pop the release lever down, and now we can move on to the solid state drive and hard drive.
All right, so like Steve said, we're going to move on to the solid state drive, the Samsung 840 250 gig, and this guy just mounts with these screw holes here lining up with these screw holes here so that it will stay nice and steady like this. And then this guy, this hard disk drive, is completely toolless. You just use these little prongs right here to snap into the screw holes here, and that's all there is to it.
And make sure your power connectors are facing out, otherwise you'll have to redo it. And next we are going to move on, I believe, to the cables. We have everything in now, so we're just going straight to cables. We'll route them through the holes and then do the video card last. All right, so if you have a modular power supply now, you can connect your cables to the power supply. If not, then you are good to go for this part. Basically, just make sure you're looking for the 24-pin connector on the power supply, the 8-pin for the CPU, and then your pinouts for the video card, depending on how powerful the video card is. And then, of course, your SATA connections, and if relevant, the Molex connections. And next, it's time to manage the cables from your power supply and your front panel connectors. So I have a full guide on that, linked in the description below. It's a pretty popular video, so hit that if you need help with specific cable management tips. In general, just route the cables through the closest hole. Try to stretch the cable out as much as possible and minimize the amount of cable length that's inside the case. This will reduce the chance of inhibiting airflow and keep dust out of your case, which also can damage components down the line. So we're just gonna cut through that, and then it's time to mount the video card.
What we have here is GTX 760 from EVGA. It's gonna go into the PCI Express S16, and it's pretty simple install. You just kind of line it up first with the outside of the case, drop in that edge, and then just let it slowly drop in. Give it a nice little tap. And then you'll put these two thumb screws in right here and then install the power connectors. You'll see that we have an 8-pin and a 6-pin. Our nice power supply has a little bit of both, so we'll line those up and install those as well.
Once you have all of the cables routed through the pass-throughs, you need to connect them to the board and the components. So we have a 24-pin power connector that's board side. That's pretty obvious. It's on the right side of the board, right of the CPU. Just plug that in. We have an 8-pin CPU connector, top left normally, right near the CPU, also known as the EPS connector. And then, of course, we have your video card power connectors. Depending on how powerful the video card is, you might have a few of those. The front panel connectors in the bottom are for your USB or USB 2.0 if you have it, LEDs, power switches, stuff like that. Check your manual for where those go on the motherboard because it is different for a couple motherboards. And finally, HD audio in the bottom left for your front panel audio. And I think that covers all of our connectors other than obviously the drives. You plug those in drive side. It's pretty straightforward with the SATA power and SATA data cables.
And you know, Steve, one of the things that you were mentioning to me earlier when we were doing the build was that some people may not have a built-in fan controller on their system. And if that's the case, then you're going to use your onboard fan connectors. It looks just like the one that we showed you earlier on the CPU. You're just going to find them all throughout the board. And that's an easy plug and play there.
And you can actually control those speeds through BIOS. If they bother you, you can drop it down to 50% and reduce the noise.
Yeah, I guess last but not least, now that you got your system built and you got it looking the way you want it to look, the last thing you really want to do is run a burn-in test. What that's going to do is just push your components to peak load so that you can make sure that they're going to work at peak load for as long as possible. Pretty much, if you can make them fail at peak load now, they're going to fail at peak load later. And if you can't make them fail at peak load now, they're probably going to last you a good long time. Check out the guide down link below.
Yep, we have a guide for that. Of course, if you have any trouble throughout the entire process, if you need help picking components or testing or whatever, determining what's broken if it doesn't boot, then check out our forums. We have free support, of course. And that's it for this guide. So let us know in the comments below, or preferably on our page, since YouTube is using Google Plus now, and I don't understand how it works. Leave us a comment somewhere on the internet and tell me what you want to see for the next video, and we will see you all next time. Peace.
Later on.